The square root of 45 times the square root of 125. The square root of 45 times the square root of 125. Now, two ways we can do this is we can factor out the largest perfect square that we can factor out. So perfect squares would be like 1 squared is 1, 2 squared is 2. So the perfect squares would be like these numbers over here, right? So 3 squared is 9, 4 squared is 16, 5 squared is 25, and I can factor a 9 out of a 45. So I could say this is equal to 9 times 5. And over here, the 125, I could factor a 25 out of 125, and that gives me 25 times 5. Now, I can break these radicals apart at this point, so that would give me square root of 9 times the square root of 5. And over here, this would be the square root of 25 times the square root of 5. Square root of 9 is 3 because 3 squared is equal to 9. Therefore, the square root of 9 must be equal to 3. So that would give you a 3 square roots of 5 times 5 square roots of 5. Now we can multiply these both together. We can multiply the stuff on the outside together. So 3 times 5. Multiply the stuff on the inside together, which would be 5 times 5. 3 times 5 is 15. And 5 times 5 is 25. Now we can take the square root of 25, which would give you a 5. And now, since the 5 is on the outside of the radical, we'd say 15 times 5 is 75. Now there's another way of doing this, which we just multiply everything together right off the bat. So we would basically say square root of 45 times square root of 125. We would multiply the radicands together. 45 is a radican and 125 is a radican. So we would say 45 times 125. And you calculate it for that. So we would say 45 times 125 is 5,625. Right? So 5,625. This pretty much illustrates the problem with this. If you simplify everything to begin with, like I did in the first example, you'll deal with smaller numbers, but you might have to simplify multiple times. If you don't simplify right off the bat, you have to deal with much larger numbers. Normally, whenever you do it this way, you're going to start doing a prime factorization. So you would say 5,625. And what you would do is you'd start trying to divide prime numbers in. Prime numbers are things like 2, 3, 5, 7, 11, 13, 17, and they're an infinite number. So we try to divide the first one. 2 doesn't go evenly into 5,625, so we move 1, 3, 3. Does 3 go into 5,625 evenly? Well, let's see. 5,625 divided by 3. Yeah, I kind of thought that might work. Okay, so we have 1,875 because we divided this by 3. Now can we divide 1,875 by 3? I think we probably can. And did we can? So we divide that by 3, and we get 625. Now, if I try to divide that by 5, though, I get a decimal. Boom, decimal. Okay, so that didn't work. So what can I divide 625 by? Well, I can divide 625 by 5, and that would give me 125. I'm going to divide 125 by 5. That gives me 25. I can divide that by 5. That gives me 5. I can divide that by 5. That gives me a 1. So the prime factorization of it is this right here. It's all this nonsense right here. Okay, so at this point, I know it's 3 times 3 times 5 times 5 times 5 times 5. I'm taking the square root of this whole thing, right? So I'm trying to pull out pairs. I have a pair of 3s. I have a pair of 5s. I have a pair of 5s. When I pull them all out, I just write them once on the outside. And what that does is that gives me 3 times 5 times 5, which is 75. So it doesn't matter which way I did it, I did 75. So if you're dealing with small numbers and radicals, you can simplify them as you go along, which is this method over here. You can multiply everything through, but then you have to deal with much larger numbers like this. But then you only have to simplify it once. Once you're done simplifying, you're done.